Okay, and I think I'm recording now. Yes, so welcome everybody. Thank you very much for connecting to this Teaching with GeoMapApp workshop. We did one in August 2020 and it was also very well attended. And based on that, I thought it would be useful to run another one, but with a slightly different format. In the first one, it was just me talking. I'm Andrew Goodwillie from Le Monde. But in this one, I thought it'd be more useful to actually have 4 professors who use GeoMapApp in their classrooms or in their labs to briefly go over some of the activities that they do. So we have 4 people here. We have Jessica Warren at University of Delaware, Joann Stock at Caltech, Scott White at South Carolina, and Rob Pockalny in Rhode Island. And each of the presenters will get about 10 minutes or so, and they will go over how they use GeoMapApp, and they've very kindly offered to give some tips on how their students may have barriers, how to get over those barriers, how to make GeoMapApp more effective in the classroom, that sort of thing. And presenters, do you want to have questions after each presentation, or do you want to hold them to the end? What would you prefer?
I think a few minutes after each, but not to take enough time to use up time that other people are supposed to be talking.
Yeah, okay, so we'll do that. All right, so let's get going then. Jessica Warren volunteered to go first. So Jessica, if you would like to take it away, you can share your screen and do what you need to do. Thank you.
Great, thank you, Andrew. Hi, everyone. So I'm going to share screen first on a couple PowerPoint slides just to give some context. So I teach a class on plate tectonics with a focus on the marine environment and the marine constraints for plate tectonics. I'm just going to leave this in the, I'm not going to go into presenter mode right now because I want to switch between this and GeoMapApp. So as part of this class, we talk about construction of the seafloor at mid-ocean ridges, and we talk about classic models for them at fast spreading rates. And then I talk about how things change as spreading rate gets slower. And this is a cartoon diagram that shows that. And then I also show them examples of seafloor morphology. These are some really nice images that you can download from the GeoMapApp website. And so I talk about how at fast spreading rates, there is this very pronounced ridge. If you go to very slow spreading rates or ultra slow, you have this deep rift valley. But then to get, and actually there's one more slide I'll show, which is just a compilation of spreading rates for all the different ridges and showing how they change over an order of magnitude. This is a log scale on the x-axis here. So this is the lead into doing an assignment, but the goal then is to switch over and have students use GeoMapApp so that they actually get a feel for looking at the seafloor, and rather than me just talking to them, they're playing around with the data sets. And so I am going to switch over to GeoMapApp and share that now. I'm actually way more zoomed in than I want to be right now. Let me just zoom out more. So this is a section of the East Pacific Rise, the 9 North section, which is a really classic locality. In the exercise that I have students do, I've chosen 4 localities. I give them the coordinates that they need to navigate to. Ideally, we have had GeoMapApp installed ahead of the class. If they're installing during the class period, then I allocate some time for that because that invariably can take longer for some students than others. And then the goal is that they navigate that split in, sorry? I see. Oh, I think somebody's it's unmuted right now. Okay. So in the class, they get split into groups, and then they're each assigned 1 of 4 localities. And actually, I am going to switch over back to the PowerPoint just to show you the overview of those. And so the 4 localities that they have, there are 2 that are relatively fast spreading rates, East Pacific Rise and Juan de Fuca Ridge, Mid-Atlantic Ridge, which is our slow spreading rate, and then the Southwest Indian Ridge at an ultra slow spreading rate. And as part of the exercise, so they do this in groups, And I initially set this up when we were doing virtual learning. So I am going to go to a Google Doc to show you what they were asked to do. It turned out actually that this worked out really well as a Zoom class. So they were split into breakout rooms. I think I had about 4 students in each group doing this, and they were each given a Google Doc that they had to fill out along with the location. And so I made sure before I went around the Zoom rooms to make sure that they were in the right place in GeoMapApp. Doing that takes some time. And then the questions in bold were the questions that they were asked to complete for each of those areas and to work through that as a group. And in fact, on this first one, the what is the spreading rate, they were also given a link to a UNAVCO website where they could calculate the spreading rate based on the lat and long. And then the next questions are asking them to make measurements and to look at the maps and think about the ridge morphology that they're looking at. So I'm going to go back over to GeoMapApp now. So one of the areas is this East Pacific Rise area. I just zoomed out by accident. So they are given this area around the 9 North region and asked to construct a profile for this. So then you use the measuring tool and they would draw a line like that. And I have too many layers up. I got to change this, but I'm not sure on the share screen if you're going to see, let me see. So they would pull up a profile, which I am now on my screen not seeing, but the white line that I drew on your own, if you do this through GeoMapApp on your own computer, there is a cross section that should come up because I did actually find things didn't always go as planned in GeoMapApp. If I go back to the Google Doc, I also had given them as backup some profiles. So this image down here is what they should have seen, and they can use that to answer questions about the width of the ridge and the height of the ridge. And then there's also questions about the ridge offsets. And so if I go back over to GeoMapApp, right, on this one, there's 2 transform faults in the area that they've been given. There's also second order offset that's here. If we zoomed in, it's possible that we would find some more offsets, but the idea was to have them think about the features that they're seeing. And then depending on the number of students, I would either have them swap and look at something that's at a slow spreading rate. So if they had looked at EPR, they would then look at Mid-Atlantic Ridge and Southwest Indian Ridge or Southwest Indian Ridge. And then, and because there's a very pronounced, in fact, I will just zoom out for those that don't look at that a lot. So one of the other localities that they were given, if we zoom over to here, so they would then go and zoom in on this area and look at this type of morphology, which is dominated by normal faulting, by an axial valley. The width of it is wider. And so the goal is to have them work through that exercise and identify those different features. Also in this case, there's a transform fault here. There's some little stepovers in the ridge, but it's a very different morphology than what we were looking at the previous location. And depending on how much time I allocated in the class, either the students would walk through 2 areas and then have a discussion afterwards about how those compare, or each group would walk through 1 area and then we would come back together and have a discussion. And in the Google Doc, one of the things that I always did was, if I go back up in it, right? So they, at the start of this, they were supposed to assign somebody to write down the answers and then also a spokesperson. And so when we came back for the discussion, we would go around and have them say what their findings had been and then have a discussion about the conclusions on that. I think the last document I'm going to share, I did write this up as just a straight Word document with information on the localities, what the questions are that they look at, the rough estimates for the times that this takes during the class, and then also some of the main conclusions that the goal is to have the students reach in comparing these different areas on the seafloor. And I think that in terms of kind of tips for running it, I mean, one of the big things, and I'm guessing some of the other presenters will say this, is just making sure that the students either having computers that have GeoMapApp preloaded, or allocating time to get the students up and running with GeoMapApp if it's the first time they're using it in class. That always takes a bit of time, and also getting them comfortable with how to zoom around and move on the map takes a little bit of time out of the class. I have, for a more intro level class, done it where I've just given them the screenshot of the different maps so that they look at it that way. But it's much more fun when they start playing around and looking at different areas of the ridges. And so I think some of it just comes down to how long you want to allocate in the class to having them finding different areas, navigating to the lat and long coordinates. I think doing that through GeoMapApp is a different experience, obviously, to how we're used to working in things like Google Maps these days. So that actually has taken more time than I originally anticipated in running it. But otherwise, it worked really well as a virtual exercise. It was a little bit of an adjustment to move it back into the classroom this year and not have them just crowd around their computers, but having them have a discussion at the end of that. So I'll leave it at there, and I'm happy to answer any questions.
Wow, thank you, Jessica. Bang on 10 minutes. So there was one question in the chat. Would you be willing to share your documents, Jess?
Yes.
Okay, so what we'll do at the end, for the presenters who are willing to share, then I will gather all the documents together and send a link to everybody who registered. Thank you. So does anyone have any questions for Jessica? I have one, Jessica, and that is right at the start of the exercise, the students use the UNAVCO plate motion calculator. Have you considered using the crustal age data set in here to get them to generate that value themselves?
Oh, that's a good idea. I had not thought about doing that, but that's a good idea. I think some of it is a little bit of question of how long to allocate to having them do that.
Yeah.
But that would be a fun way to have them do it.
Yeah. And I'm going to very quickly hog. Let me see. Can you see my screen here?
Yep.
Okay. So for people who are not familiar, if you go into data layers, geophysics, lithospheric plates, and go down to Dietmar Muller's crustal age data set, then it comes in, and let's just go, say, to the South Atlantic. Oh, I've gone in a bit too far. Let's just come out a bit. And then if you draw a profile, you can go along the flow line, something like this. And do you see the profile window here?
Yep.
Okay, so this is the distance along the profile and the age of the seafloor. And so the students can use the gradient or 1 over the gradient to calculate the spreading rate from this. And I think Scott's going to show quickly at the end one of the learning activities that we wrote that uses this to calculate spreading rates. Okay, thank you very much, Jessica. Any other questions or comments for Jessica?
Jessica, can I ask you again how long this took within the class that you delivered? Is it a single class session, and how many minutes kind of?
Yeah, that's a good question. So it ended up taking having them complete that set of 5 questions took about 25 minutes. And then I had a 15-minute class period for this. So we then spent about 10 to 15 minutes afterwards having a discussion. And that 25 minutes was actually with them just looking at one area. And so this was at it was a kind of advanced undergrad and graduate level, but getting, I think some of the time is just getting comfortable with doing things in GeoMapApp and learning those tools, because that was the first class that we had done the exercise in.
What did the students have the most trouble with?
I think it's just getting used to moving around and to even to navigating to the lat and long that I had given them, and being comfortable doing that, and then also remembering the tool. I would show them ahead of time how to draw the cross-section profile, but of course then when they go to do it, because they're all a bunch of buttons and options up there, so then having them do that on their own is not as quick to do it. So I found it's just that all the steps took them longer than what I anticipated initially.
Mhm.
Okay, thanks a lot, Jessica. So moving over to the West Coast, Joann Stock at Caltech is going to be the next presenter. So thank you very much, Joann.
Oh, thanks. Can you guys hear me? Okay, I'm going to share two documents. The first one I'm going to share is this is an example that I use in plate tectonics class, which is plate tectonics class is a geophysics class for upper level undergrads and graduate students. It's required for the first year students in geophysics. And we also, like Jessica, use most of the examples from the oceans. And so the students are they're using GeoMapApp, I would say regularly. Since it's a 90-minute class session, I break it up in the middle for a 5-minute activity and a group discussion. So this is an example of a group activity. And what happens here is that I actually make 6, this is for a set of 12 students. So I make 6 of these cards that have it's all the same example except for different locations, okay? And it doesn't have a Latin long because I want them to go into GeoMapApp. I want them to be using it in the classroom on their computers and have an internet connection and actually figure out where these locations are. So people usually can find Iceland. If they have to go then and find Wanfuka Ridge, that's okay. If you send them to Carlsberg Ridge, they might have to think about where that is. But the idea is that I have 12 of these cards and they're duplicates so that each person grabs a card by, randomly, and then which pair of people has the same number of card, they work together. So there's 2 students doing each activity. I guess you could modify this to have like 4 students if you had more students, but what they have to do is go to GeoMapApp and then answer these questions. So they have to identify the lat long of the location, the trend of the magnetic anomalies. They're looking at EMAG2 data set, and then they're looking at the magnitude of the anomalies, and then we will then compare everyone's results. So I'm going to now share GeoMapApp so that you can see what we would do in this case. Okay, so if you guys can see this. This is for if you had well, let me go back to the window. Let's see, the projection is, where's it? Bookmarks, global scale. Okay, so they will start with this and then they'll have to figure out where their study area is. And so for the people who have, for example, the Galapagos Rise people will go here like this, right? And then they will have to load up a data layer, and they will have used GeoMapApp before, so that I'm trying to get them familiar with looking at different data sets. And so for geophysics, they will look at the magnetic anomalies, and we'll just say EMAG2 here. And then that will be an overlay. And then they have to figure out what the amplitudes are of these magnetic anomalies. And so once it loads, they would then use this profile tool. Let's see, something is blocking my screen here. Okay, so can you guys see, I don't know if you'll be able to see the profile, maybe not, but this would be what they would do. Do you guys see the profile? It might be the same problem that Jessica had. I can't hear you guys. I don't know if you're seeing it or not.
I think
with a white line, but we don't see a profile.
Right. Okay. So
I think you have to share your whole desktop to be able to see the profile as well.
Okay, so I'm just doing the share now for the profile. Okay, so what they would do with this is they would be able to use it to look at the amplitudes of the magnetic anomalies, and they would write on the card what the values are. And then they would go back. They would also look, so let me go back to the other screen. I will stop sharing this. And I will share back the magnetic anomaly profile screen. So then what they might have to do here is go into the layer manager, which you guys also probably can't see it, but they might have to reduce the opacity of the data set. so that it looks like this.
We
so
can
they
actually see that, Joanne. So if you just move the layer manager a little bit to the left, we can see the whole layer manager window.
Okay, so how about that? Okay,
Yes,
so
perfect.
yeah, so they're getting used to looking at, doing some activities in GeoMapApp, including the, playing with the layer manager, making the profile. They could add other layers, turn them on and off, and things like this. And so they would be able to measure the trend of the anomalies from looking at the map, and they would already have known what the definition is of trend on the map. So we did that already in a previous part of the class. And so this is just one example of like a short activity that they would do. And then the eventually in the class, they will have like a big set of homework assignments where they have to make maps of a particular study area with lots of different data sets. So they'll have to do like a gravity map, a bathymetry map, an age map, the magnetic anomaly map, etc., so that they get a sense of putting all of this data together. But for the 5-minute exercise, they don't do that. And then the other reason that I do this, let me stop sharing and I'll go back to this card thing that we use. The reason I do this, where did it go? Nope, that's not it. Oh, right, okay. So the reason I do this way is because in my class, I usually have some grad students who are like from other countries, right? So there might be like 3 people from China and then some other people from some other countries, and they never want to talk to each other because they aren't comfortable. So on the back of the card, they have to write the name of themselves and their partner, whoever it was who did this activity. And that way I use it to make sure that they get to know each other better, and also as a like an attendance check for who is in class. So that's it. We also do this for other data sets too, but that's just one example.
Thank you, Joanne. And do you find that it deepens students' understanding of the data sets that they're investigating?
The webinar on GeoMapApp.
Yes. So I think that the fact that they only have 5 minutes to do it means they go back and look more later at it as they are working on their bigger projects, where they have to include, the gravity and all these other kinds of data sets, all of which they have in GeoMapApp. And so for their final papers, they have to make a whole set of figures and discuss them for like one study area, and each person has a separate study area.
So any other questions for Joanne? And a similar question, Joanne, as Jessica was asked, do you find that there are particular things that trip up the students?
Yes, the first thing will be to know where it is they're supposed to go, because they may not know where the Galapagos Rise is or what the Carlsberg Ridge is. And so they have to go find that information out somehow, usually with their cell phones, that they're looking at things up on Wikipedia. And then they can go find it in GeoMapApp, and then they can look at it and see they can see the feature in GeoMapApp, and then they can locate a latitude and longitude for it based on the window that shows up in GeoMapApp for the location of the cursor. And then if they have trouble, since they're all doing this together in the classroom, they can ask for help either from other students or from me or the teaching assistant.
Okay, we have a question came in through the chat. Do the students stick to one setting all semester, I guess one geographical setting, or do they, I guess, switch to different ones?
Well, so in the classroom examples, we use different ones all the time. For their final papers, they have each chosen a study area. And so part of the homework every week is to make some kind of map or interpretation of some data set that's just for that study area. And so each person has a different one that they're sticking to for their final paper. But in the meantime, they're using all this, they're looking at a lot of places briefly. And then actually at the very end of the class, they each have to do a 2-minute speech about their study area, and then answer questions from the other students.
Right.
So I find it most challenging for them to figure out how to, they have 2 minutes and two overheads that they can use, or 2 slides. And that's actually really challenging to make them only think of what are the most important things to say and convey that in 2 minutes to the class.
Right. And I see that Suzanne has her hand up. Suzanne, do you want to ask your question?
Yeah, thank you. This is really interesting. How have you prepared the students? I mean, how familiar are they with GeoMapApp before you give them this assignment?
So they have seen me use it in class just about every day to show them how to do things. Well, we meet twice a week, so it's 2 1.5-hour classes each week. And then they usually have one assignment, they have one homework a week, and usually one question on the homework has to do with something with GeoMapApp. So they wouldn't have used all of the data sets necessarily, but they should have an idea of like how to navigate and how to, you know, set a color scale that's appropriate for their data.
And Michael, go ahead and ask your question.
Yeah, my question is how they integrate and create the maps.
What I make them do actually is make a set of several different, like they'll make like 4 maps of different data sets, and then they will have to take tracing paper. All those maps are at the same scale, so then they have to make their own tectonic map interpreting all of the features that they consider important, which will be different from place to place, but would include things like, you know, the mid-ocean ridge, non-transform offsets, traces of propagators, feature, you know, seamounts, depending on where they are. Yeah, but their goal at the end is to look at all the stuff, figure out where everything was with the data sets, look at like traces of triple junctions from, you know, off magnetic bites and things like that. And then
Okay, so they're creating images and then using tracing paper to then do a compilation map.
yeah, some people, they want to put it all in like a computer program and trace it all by hand, or, you know, trace it with the computer, but actually that's really slow. So it's faster if they just do tracing paper, but I leave it up to them. Yeah.
Okay.
So a chat just came in. Is there a way to do that tectonic interpretation in GeoMapApp itself? And if you can find more money for our developer, maybe, but not at this moment. Okay, any other questions for Joann? All right, thank you very much, Joann. So next up is Rob Pockalny at the University of Rhode Island. So Rob, if you're ready, take it away.
Can you see my screen?
We can see you.
Oh. How about now?
Yes.
Excellent. Okay, so what we do at the graduate school is a little very similar to what Jessica put out to introduce our graduate students to GeoMapApp. So what I decided to do, instead of repeating that, and I'd go into something I often do for workshops for graduate students and even faculty, a little more advanced sorts of things. And I think that's a little more advanced in some of the skill set, but I still think it's potentially scalable to undergraduates, especially upper level undergraduates. So I haven't done this one exactly before in a workshop, but I tweaked it this weekend to see if it might be a little more timely appropriate. And so I was kind of focused on manganese nodules. So I have a focus question: can environmental factors, basically location, sediment properties, be used to predict the distribution of nodules? And the goal here is to identify the environmental factors to potentially identify, as well as potentially, in the apply aspect, is Clipperton, Clarion, lease block a good candidate for these sorts of things. So you can see the characteristic look of nodules on the seafloor and the couple of ideas of how they're formed. It's still kind of up in the air, but they have some dihydrogenetic nodules at the surface, you know, absorbing materials or precipitating materials in the water column, all the way to diogenic nodules where it's precipitating stuff within the sediments. And here they kind of show a depth range of about 4,000 to 6,500 meters. So I want to continue on with this sort of thing. And so, yeah, okay. And so some of the skills that we want to look at, I'm mainly working with multiple data layers. So I'm going to load ones that are included in GeoMapApp, as well as import a shapefile in Esri GIS format, and import a CDF grid that I created too. And then maybe do a little tweaking of the layers to identify. There's some of the opacity changes that Joan was showing that are very useful. And what I try to always do is couch this into some sort of a focus, explore, reflect, apply model. So the focus questions on the previous page was what I drive to try to get them engaged. And then we move on to using the GeoMapApp for the exploration. And so these are some of the factors that people say are forming the polymetallic nodules. So there's a low sedimentation rate, which is pretty characteristic. And they also talk about oxygen supply in Atlantic bottom water, which I'm not going to really cover too much here. But there's also aqueous sediments, or sediments with high porosity. So we're actually going to try to explore the first and the last one in a little more detail. And so first of all, I kind of break it up into parts, like 15-minute chunks. And so the first thing I'd probably do is load the database for the GMRT. So we bring this in, global models, GMRT, and I don't know how many times I've swore at you, Andrew, for making it difficult to select these things.
No, Rob, you can take the shortcut and just click on the grid symbol.
I know for that one, but there's other ones too.
Okay.
And so just to be able to see things, what I do is I kind of change it to 6,000 to minus 2,000. You kind of have all these directions here. So you can actually start to see a little easier the depth. Did that change anything? Oh, because it's not showing it. I have to click it. There you go. So it modifies it, it changes the colors. And then what I'm going to do is I'm going to import a shapefile from a recent paper by Kira Mazel. And just go over to File, import a shapefile. It's on my local computer. And all these files and everything are on a zip file that I sent access to to Andrew. So it'll load, and sometimes it takes a little bit longer to load. Come on. Don't make a liar out of me. Oh, there it goes. Good. Wait for it. There it goes. And so you kind of see the black circles where they think the crusts are occurring. It'll pop back up. And just for ease, what I do is I'll change the color and just make it white. And sometimes you have to, there you go. So now it's showing white. And then I have them ask questions. And I kind of do this in a workshop format, and I'll walk around. And so what you do is let's use the profile tool that we've spoken about to measure some things. So we select the profile tool. And let's just go into this. This is a Clarion Clipping area. And it shows up as a straight line, but you can do this in a great circle too if you wanted. But it shows a great circle, but I like the straight line. And what I've always liked about GeoMapApp, how it works, is that every time where you have the cursor in the profile, it shows you where you are on the map. And I just love that. And so if you look at this, it gets, this one is like 4,000 to 5,500 meters where they actually see the nodules. And you can kind of do all the other ones, and they all end up being deeper than about 4,000 meters. So that may be one of the environmental factors we can use. But to kind of demonstrate that a little better, what I can do is use a contour tool here. So if I click on here, and I use a 4,000 interval, Boolean interval, and here I'm going to go minus 5,000 to 0, and you can see all the numbers that I use to do this. And if you click on that, and hopefully it'll show the grids for the depth interval there. And very quickly you can see how almost all these bodies are deeper than 4,000 meters. So that's one of the environmental factors that they could use to look at these things. And so because things kind of take a while to deal with, I always hide the layer so it doesn't have to keep displaying. So I click there and hide it. Don't want to click on the X because that gets rid of the whole thing, but at least that one kind of puts it, you can still hide it. So then I go to the next one, And let's look at the sedimentation rates. And so this is a file I created, several years ago. And it basically just take the Divens and Mueller databases and divide it. Look, and it's a time averaged integrated sedimentation rate, so it's not an instantaneous, which would be preferred. So what I can do is I can import this, a 2D grid file from a local system, and say it's okay. And we already opened the earlier one. So here's my sed rate 2012 that I created. Open that, and it asks you certain sorts of things. We're not going to change anything here on this one, but we will on another one. All the information, then it loads. And then the interesting thing to note is that you can't really see the nodules thing anymore, so you have to keep bringing this up to the surface. And in advance, this is one of the things that kind of catches people. Like, don't realize they have to keep changing the order of the different layers to see these things. And so now you can see them here. And so this is the sedimentation rate. And so this actually isn't sedimentation rate. This is the porosity. This is what it's supposed to show at the end. But anyway, so what you can do, you can actually modify some of the features here. And this is one odd thing, Andrew. I'm not sure why sometimes it selects the wrong database to show these sorts of things. But anyway, and so what you can do is, this is a grid that I created that I can load. It's the NetCDF format, and so you can actually modify, if this was the correct database, kind of go back and forth and kind of narrow in the region. And so I'm going to hide this layer, and then I'm going to bring in another database that's on the GeoMapApp. So now I can do file, import, 2D file. Actually, no, I want it to data layer. Geophysics, geology rather, sediment photos, sediment composition, and I use the Dukevich one. And I'll bring the nodules back up to the surface if it loads. Okay, pops up. And so you can see the different sediment types here. You kind of see the colors of them anyway. So the brown ones seem to be most related to these sorts of things. You can change the opacity of this to highlight it better. What I also like here is they have a link to the website for it. So you can actually click on this, and it'll pop. Let me grab it from my other screen. It'll pop up the article. And you can actually see the color that's correspond to that is clay. So this is the clay province, red clay province. And you know that it's going to be very low sedimentation rate. So that's the one of the aspects I like. And the last thing I don't want to go over that I have here is the sediment porosity one. So again, this is the 2D one. And this is where it was supposed to be sed rate. But you can actually see that the porosity is a really good match. So your higher porosity is where you're going to have these sorts of things. And what you saw before with you would have seen that the Antarctic bottom water does come up here and does impact that area. But you can see the porosity does kind of match really well with where you have these sorts of nodules occurring. And so I kind of go back to reflect on this. So low sedimentation rate does correlate with low sedimentation rates, also indicated by the actual depth integrated, as well as the red clay province, and also the aqueous sediments where you have high porosity. And there is some more here, but I don't want to take up too much time. But you can actually try to apply this to say, is the clarion-clipperton a good potential source for these nodules, and which portion would you think would be the best? And what you can do is what I always do the you do the shift command 4 to grab a portion of this region, and you note the lat long for this thing, and then you can use the overlay image, add image overlay, and this I just already did this, and it'll allow you to select the north, south, east, west, and it'll actually lay it on top of it. I'll just do it real quick to show you how it works. and it nicely shows up in this region down here. So you're gonna, georeference it at some level. Yeah, kind of see these sorts of things, do these little layers in and out. That's basically all I have. Some of the tools you can have. It's all should be in this PowerPoint. Some of the directions on how to do it, and the comparisons, and I have screenshots of what it may look like for reference. So that's all I have. If anybody have any questions.
Oh, thanks a lot, Rob. That was fascinating. So does anyone have questions for Rob? And if you have, keep them short. He has to run off to a thesis defense soon.
I still have 15 minutes.
Okay. Right, Jessica?
I have a quick question. Did you say how long this takes?
Well, each of the sections, I like to try to chunk into 15 minutes. So there's like a part A, part B, part C, and part D. And so when I try to, get them set up with the next step, and then kind of wander around the room, make sure they can all do it, and then take time to talk about it, reflect afterward. So I just like to chunk it, 10 to 15 minutes for each of these parts.
Great, thanks.
And Rob, I have a question. You kindly zipped all these files up for dissemination. I just want to check they're all public, right? Publicly accessible.
Yeah. No, yeah, they are. They're some of them are on GitHub. That the porosity one and the other ones are the ones I've used or created that have been published too.
Okay.
So,
all right, thank you.
and I try to provide the appropriate attribution to each of the images and figures too.
Right, great. All right, this is a perfect workshop. Everyone's so on time here. It's great. So
I have a question for Rob before he leaves.
yes.
Capturing that georeferenced image and pasting it in the GeoMapApp, does that require a special kind of image on a web page? Is it a?
I just grabbed it from a ping file I saw online.
Okay.
Yeah.
And then you have to manually put in the extent of the map?
Exactly.
Oh, okay.
You can import JPEGs, PNGs, and PDFs, I think.
Yep.
Okay. But okay. If it's like a JPEG 2000, I think those are georeferenced. Would those go in without having to manually type in the extents?
No, we can't handle JPEG 2000 yet.
Okay. Thank you.
Okay, so if there are no other questions for Rob, thank you so much, Rob. The last presenter today is Scott White from the University of South Carolina. So Scott, if you would, Rob, if you can unshare your screen.
No, I want to be in charge of everything.
and Scott, thanks a lot, Scott.
So, hi, I'm going to do a little bit different. So my name is Scott White, and I want to talk to you today about how I use GeoMapApp as a platform to deliver my geological oceanography course. It's an introductory graduate level, but also upper division undergraduate level course. In the past, I've used one or two GeoMapApp assignments or modules in previous courses. And for various reasons, I felt like this course, I wanted to integrate the entire course to use GeoMapApp throughout. I think this particular course is an experience that I'd like to talk about and share with you and discuss. It would be readily transferable to plenty of other disciplines and levels. How I use these sort of previously existing library of educational modules to make this an easy way to integrate GeoMapApp into my course and teach the content throughout the entire course. As the reasons I did this are listed on the slide. Lots of existing content, some wonderful examples of things that we've seen today, so constantly being updated. A good tool with a faster learning curve for the students than a full GIS, and the repetition of bringing that back again and again, like Joann mentioned, builds some comfort in the students with using those tools and some familiarity, which helps them with their own research down the line. So I'm not just giving them content, I'm giving them kind of a tool in this way. And so some trial and error, and again, like I think I'd like to hear from you guys what you think about this. There's a lot of drawbacks to just throwing them into GeoMapApp exercises without a lecture introduction or a theory. This was a 2-time-a-week course, a Tuesday, Thursday format. So it was really easy to do one, which was a lecture introduction, theory on the subject, and then the other one, which is entirely devoted to the GeoMapApp in-class assignment. And so what I'd like to do is I will show you how this worked in terms of what I used to cover the courses and the topics in terms of the modules. All of the modules were pretty much used just kind of off the shelf, but I did add a couple of little tweaks to them as we went along. And so this will go pretty fast. We did an introduction to GeoMapApp, which definitely needed, rather than throwing them into a frustrating experience with having a assignment where they had to turn things in to me and learn the interface at the same time. This really helped, and this is where we got this from, the CERC website, GeoMapApp learning exercises. And so the first one we did was the introduction to exploring Earth's topography. It's a fairly simple exercise, but it was really valuable for them, even though the questions were pretty basic, to just learn the interface. And they learned about ocean basin shape, which was the subject that we covered. And we went from sort of ocean basin formation all the way up to paleoceanography in this course. And so then we talked about seafloor spreading, using this seafloor spreading activity. It's pictured on the right there. And I'll share a document with all the links to these different modules that I kind of cobbled together. Bathymetry and isochrons that Andrew showed us just a little while ago, and pulled in some margins exercises to demonstrate isostasy and sedimentation. As we started moving into subduction, after talking about subduction in class, the students got to go out and fumble around with this exercise, which was great because they got to look at a bunch of different trenches, sort of the way that Jessica has them look at a bunch of different spreading ridges. They looked at a bunch of different trenches and then calculated what the seafloor looked like. Really eye-opening for a lot of them. I found that had backgrounds that were sort of chemical oceanography or biological oceanographers hadn't considered the impact of seafloor topography or what it was really doing. And then bridged into sedimentation on the seafloor with another exercise from the margins mini lessons, which I found were great. Pretty well prepared lessons. And then finally, this exercise on paleooceanography, looking at drill core, and in this, having to bring in data sets from outside and go out and hunt for them and bring them in. So the way that Rob was showing us in his exercise as well. And so by the time that we wrapped all of this up, they had this whole suite of tools that they could use to apply to their own projects, which was a capstone component of this course. And so they learned each tool sort of incrementally as part of the design of the curriculum of this course. And the way that we did this, we had about an 80-minute class period, which always kind of smushes itself down when you lose that beginning of class where people kind of trickle in, and that end of class where people pack up, to dealing with the assignment. Each one of these assignments online seemed to take the students about an hour to accomplish. And I either had them fill out a paper or just an online worksheet, and going through step-by-step instructions that most of these had was, a great learning exercise for the students. And the class went a lot better when I kind of walked through that with them in the beginning, and then just let them go. We didn't bother to kind of chunk it up or stop and review. Students were then able to kind of blast through the whole exercise. Once they kind of became familiar with the program itself, things started moving faster. We have a computer lab, there were computer terminals, but about half the students or more just used their own laptops. They really preferred that mode, and they were great at just working with people who were adjacent to them. And then the the really valuable part about this is once they got to the end of class, we had a full class discussion and some of the more open-ended questions on the handout, which is pretty similar to what Rob Pockalny was talking about with his exercise. There were questions that inevitably arose that revealed students' gaps in understanding when they had to complete the entire assignment, and that we were able to address in the full class discussion. And the students really were able to engage with those more open-ended questions by the time they had had all the introductory material and then the open-ended question at the end. And they really like to be able to share and compare those answers. It created kind of a lower stress environment by including that discussion there at the end. And so that would be one of my tips. And so, I just wanted to wrap it up with some concluding thoughts about structuring an entire course around just doing a bunch of GeoMapApp exercises explicitly in class. You guys probably already know this, but it seems feasible to design an entire course around GeoMapApp without too much overhead from existing modules. And one of the things, the revelations that I had is that needed to keep bringing the students back to this almost on a weekly basis, really on a weekly basis, to kind of get their comfort level up with doing this. But once we were able to do this for about 6 or 7 weeks, they then were off and running with GeoMapApp as their own tool, but it took a while to build in. And so that's it. And you might be able to access this Google Doc, but in any case, I will give it to Andrew and he can share it as well.
Okay, thank you very much, Scott. So any questions for Scott?
Close to the end time.
And so Scott, do you think once people leave your class and progress through their university courses, do you see evidence of them using GeoMapApp in other settings?
Yeah, and I think that was the primary motivating factor behind structuring this entire class around GeoMapApp. It sounds like Joann does kind of a similar thing, but when I was just doing 1 or 2 exercises, I would get questions afterward about, well, how do I make a map showing this or that? Just because most of my students, they're not really geologists, they're more oceanographers. And making maps is difficult, or can be difficult. It can be a hurdle for them in presenting their dissertations or later on. And GeoMapApp is, as you guys all know, such a really great tool for being able to do that. That repetition, I think, helps them out a lot. I see those GeoMapApp plots, they kind of got that specific look to them that appearing later on in journal clubs and talks and things.
All right, Jessica, do you have a question?
I had a kind of a follow-up comment to what Scott was just saying, which is that I agree that you do need to use it across multiple classes for the students to be comfortable with it. I'm using it in one exercise because it's balanced against other goals in the course. And so I know, I can see just from the time utilization in the class that, that part of that time is them learning how to use the tool, and we would really need to be returning to it weekly for them to get comfortable with it. I do hope, though, at least that in using it in one class, that some of the students are aware of it for their own research needs later on.
And Joann?
Oh, yes. Also, to follow up on that, I think it is important to have students use it more than once. But the other thing that's turned out to be very helpful for my students is that they can use the links in GeoMapApp to get the databases or get the links to the sources of the data, as Robert showed. And actually, part of one of their assignments, they have to write a complete citation of where they got the data from. So they're doing figure captions, but they have to put everything in the figure caption that explains like where the data is from. And they use GeoMapApp for that. And I think it's really valuable for them later when they are then writing their own papers to understand how to get back to the sources of things like bathymetry or gravity data.
Yeah, so that's worth picking up on. In the database that drives GeoMapApp, we try as best we can to link every single data set to the source document. So in the layer manager window, you'll see the little tourist information eye symbol, the blue circle with the eye in it. And if you click on that, it should take you to information about the data set. All right, wonderful. Any other questions for our presenters? So we'll just show you where to find some of the education modules that Scott showed. So let me, I think you can see my GeoMapApp window now, is that correct? I don't see if anyone's nodding. Can you see that? Yeah, okay, great. So if you go into the education menu, then you can see the different links to here we have the old Earth exploration chapters, then the GeoMapApp learning activities. These were ones that I actually created with a master teacher for middle school and high school or intro level. But as Scott showed, you can adapt them to university levels as you please. And then the margins and geoprisms mini lessons. And there's some other links in there too. Okay. So let's see, we are at 1:59 New York time. How about that for being on time? Are there any final comments or questions that any of the participants have? A couple of comments coming in on the chat, thanking the presenters for the resources. That's wonderful. I will say that as you probably know, if you've seen us do workshop presentations, if you have questions or requests, Joann knows this well, you want to see data sets that you're aware of but are not yet in GeoMapApp, then let us know and we'll do our best to add those to GeoMapApp to the built-in menus. Okay, so if there's no other comments or questions, then I think we should wrap it up there. So thank you very much to Jessica, Joann, Scott, and Rob for being presenters and for everyone who's joining. And I will send around the recorded link and also a link to the resources that people used and the documents. So thank you very much, everybody. Bye-bye.